Hello students and teacher friends. In this particular video I am going to solve a numerical problem which is based on moles, but it's a multi-step problem and it may carry up to 9 marks, so it's sometimes very overwhelming for the students because it's a long question, and when they read the question they find it difficult to understand from where to start and how to go about solving the problem. So I am going to show you all the steps in an easy way so that you are able to solve similar type of problems. This type of problem may be there in your practical exam paper as well. So the question goes like this: the chloride of an element Z reacts with water according to the following equation. ZCl4 plus 2H2O gives ZO2 plus 4HCl. A 1.304 gram sample of ZlCl4 was added to water. So in this type of question it is always better that we try to picturize what's happening so that we can keep track of all the steps. So I have done that and I'm going to show you. So let's try to picturize what is happening. So a sample of ZCl4 was added to water. So we can write something like this, that water is added to ZCl4 and the reaction which takes place is this, which is already given. And then the solid ZO2 is removed by filtration and the resulting solution was made up to 250 centimeter cube in a volumetric flask. So again, try to picturize what is happening. So I'll show you that. So see, once this reaction is over, suppose this reaction has taken place in this beaker. So ZCl4 was taken and water, little excess was added so that all the ZCl4 reacts, and the products are ZO2, which is a solid, and the 4HCl. And now the contents in the beaker are filtered so that the ZO2 was a solid, so it will be trapped on the filter paper and the aqueous HCl would be transferred to your conical flask as a filtrate. So this is what has happened. So let's see then what more is going to happen. So the resulting solution was made up to 250 centimeter cube in a volumetric flask. So what we have done is here is that once this solution of HCl was obtained, so a 250 centimeter cube of the volumetric flask was taken and the volume was made up to 250 centimeter cube by adding water. So up to this time this has been done. Now we proceed further, and 25 centimeter cube portion of this solution was titrated against 0.112 mole per dm cube solution of NaOH, of which 21.7 centimeter cube were required to reach the end point. So now again try to picturize what happened. So we took 25 centimeter cube of this solution with the help of pipette and we transferred it into this conical flask and we titrated it against 0.112 mole per dm cube of NaOH solution, and we required 21.7 centimeter cube of the NaOH to reach the end point. So this is what has been done, and now we come to the calculations. So calculate the number of moles of ZCl4 present in the sample, calculate the relative molecular mass of ZCl4, and then we can deduce the atomic mass AR of the element Z. So now the information that we have got is that we took the 0.112 mole per dm cube NaOH and 21.7 centimeter cube. So we can definitely calculate the number of moles of NaOH used, and then we can calculate the number of moles of HCl which are present in this 25 centimeter cube. So let's do that. So the the number of moles of NaOH would be C times V, 0.112 times 21.7 divided by 1000 to convert it into dm cube, and we get 0.002430 mole of NaOH. Now since the ratio is 1:1 of the reaction between NaOH and HCl, the moles of HCl in the 25 centimeter cube of the solution would be the same, 0.0024304. But we have to understand that we had removed 25 centimeter cube from the 250 centimeter cube, and therefore we must know how much of HCl was present in the entire 250 centimeter cube of the solution. So obviously if we know in 25 and we want to know in 250, the factor will be multiplied by 10. So we get the number of moles of HCl produced in the reaction, which is 0.02430. And now we consider the stoichiometry, that 1 mole of ZCl4 and 4 moles of HCl. So the number of moles of ZCl4 will be 1/4 of the number of moles of HCl. So we divide it by 4 and we get the number of moles of ZCl4. Now since we know the moles of ZCl4, and we can find out the MR by dividing the mass by the moles. So the mass of ZCl4 that we had taken was 1.304, and we know the number of moles of the ZCl4. We get the MR of ZCl4, which is 214.61, and then we can subtract the contribution of Cl4 from this molar mass. So it would be subtraction of 4 times 35.45, that is 141.80, and we get 72.81 as the AR of Z. And if we look at the periodic table, it corresponds to germanium, which is very close to the value that we have got, 72.81, and the closest element is germanium according to the periodic table, and hence our unknown element Z is definitely germanium. So I hope that you understood the various steps involved in the calculation of such type of problem, in which there are many steps and we have to find the, in this particular case, the AR of the unknown element Z. Thanks for watching.